based off this warm-up, what is our definition of congruent that we've used in the past? Equal or the same? Okay. So if I had two lines, I want to show two lines are congruent, how would I go about that? What needs to be equal or the same for two lines to be congruent?
Measurement.
The measurement or their length. Measure of their length. So it doesn't matter which way the lines are oriented. I could have one vertical and I could have one horizontal. It doesn't matter for that. We just want the measure of both those lines to be the same. If one's 8 inches, the other one has to be 8 inches. If one's 12 centimeters, the other one has to be 12 centimeters. It doesn't matter which way those lines are going. They just need to be the same length in order to be congruent. What about for angles? If I want to show two angles are congruent, what would I need? What needs to be the same for that, or equal? The angle measure or the degree measure. Good. So in order for two angles to be the same, they have to have the same degree. So if one's 34 degrees, the other one needs to be 34. If one's 81 degrees, the other one needs to be 81 degrees. It doesn't matter if one angle is pointing up or one angle is pointing down or one angle is longer than the other, one angle is short. They just need those same degree measures, and that will give you congruent angles. Colton, let's put your phone away, please. Put your phone away, please. It looks like it's distracting you, so put it away. All right, so we've talked, or in the past we've talked about congruent angles and congruent lines. So we're going to take this, our definition of congruence, and we're going to expand it to now shapes in general. And what means, or what does it mean to have two congruent shapes, or what does it mean to, or for two shapes to be congruent, and how can we use that? So just based off of our congruent information so far, if you were to take a guess, what would you say the definition, or what would you say two congruent shapes should be, or what would you think a unique factor about two congruent shapes would be? What are some things that should be true if two shapes are congruent?
All of the angles and shapes are the same.
So all the angles are the same? So do you think that means every angle, like if I have one shape, all of these angles are going to be the same?
No, in the second, third.
So like this angle matches with this angle, and this angle matches with this one. Alright, so they sort of have like corresponding angles?
Yes.
Okay, good. I like that. That sounds good. What else would need to be the same for two shapes to be congruent? It would have to have all the same side lengths, or corresponding side lengths. So that one would be one, this would be. So this is essentially our definition of corresponding shapes. If you have two shapes that are corresponding, all of their sides are going to have a congruent corresponding side on this second shape. All of their angles are going to have a congruent corresponding angle on the second shape as well. And it works both ways. So if two shapes are congruent, they have congruent sides, congruent angles. If two angles are, or two sides and, or two shapes have congruent sides and congruent angles, then those shapes are automatically congruent. It's sort of works both ways. So lines and angles are congruent implies that the shape is congruent, and having the shape being congruent implies that the lines and angles are congruent. It works both ways. And we'll talk more about in the future how to prove shapes are congruent and how to learn and determine whether two shapes are congruent. But right now we just want to use this information and learn how to read congruence and sort of how to apply it to different situations. But we'll talk about proving congruent shapes in the future. So that's our sort of definition of a congruent shape. So when we have congruent shapes, we have things called congruent statements. And so what a congruent statement is, it's a sort of a phrase or a little way we write it, or write the names of the shapes in order to tell us what parts are congruent with each shape. So where is the corresponding congruent side of AB? Where is the corresponding congruent side of BC? And which side is corresponding to AC? And based off this congruent statement, we can read them, we can determine which sides are corresponding, or which angles are corresponding, and use that to help us solve pieces of information. So on these triangles, based off of how they're oriented and based off of their side lengths, you probably can figure out which sides are equal to which sides. But we'll talk about how to read it from the situation. So a congruent statement is always based off of two things, or you have main pieces of information. You have the name of each shape. So I have triangle ABC, and I have triangle XYZ. So my points are A, B, and C, so I can name it ABC. My points are XYZ, so that's the name of it. The little triangle to help make the triangle. Once again, that little symbol in the middle, that represents the word congruence. That little equal sign with the squiggly above it, that's our symbol for congruence. So what this is saying is triangle ABC is congruent to triangle XYZ. That's how you would read this statement. And so we can use it to help us determine some pieces of information. So if I want to figure out what side is congruent to AB on my second triangle, I can look at my congruent statement and I can see AB, that's not the point, AB is the first two letters of my congruent statement. If I look on my second triangle, the first two letters are XY. So AB and XY are then corresponding and congruent. So I know if AB is just a single hash, then XY should be a single hash. And remember, we use those hashes to determine which sides are equal length and which sides are equal to each other without using necessarily numbers. So AB is corresponding to XY, and BC is corresponding to YZ. So BC is two hashes, that means YZ is two hashes. And the last one, we have AC, it's two outside numbers, and XZ are two outside numbers. Those would then also be corresponding. So we can use these corresponding statements or congruent statements to help us determine which sides are congruent, which sides are equal to each other, and that can help us solve problems that we'll see a couple examples in the future. But it doesn't just work for lines. This also works for angles. So I can do the exact same thing with angles. I have two triangles, ABC and XYZ again, and I can figure out which angles are congruent to each other based off of that congruent statement as well. And we use the same method. So A and X, both are the first letter, so that means angle X is congruent to angle A. B and Y are the middle letters, so that means angle Y and angle B are the same. And lastly, angle C and angle Z are all congruent. So based on these congruent statements, we can match those side lengths, match those angles, which can help us then solve for things in the future. Are we okay with how I'm reading these and how I'm pulling the information from? So really it's just being able to look at those, looking at those congruent statements and being able to determine, okay, first letter, those are the same. Middle letters, those are the same. And just sort of go through and be able to sort of piece together which ones are equal to each other. You don't have to do the highlighting thing of highlighting the letters. That's just something I use to be able to help me remember which letters pair together. It's just a strategy I've come in to use. Of course, you're not restricted to that. If something else works for you to help you be able to match them together, and go for it. If you don't need anything like that at all, don't worry about it. But that's just something I use to help myself. So let's look at some examples of using these congruent statements to help us solve for some things. Help us solve for some side lengths and missing variables. So I have three missing variables on these triangles. I have W, A, and K. So those are my three missing variables. I want to use this congruent statement and the knowledge that these two triangles are congruent to each other to be able to match the sides together and figure out, okay, which side lengths are which, and how can I solve for those variables. So once again, we want to use that congruent statement to help us figure out which side lengths are the same. So AB, I'm told, is the same as XY. So AB is 13 degrees. So I know that is going to be equal to XY, which is K. So just by setting it up, I've already solved for K. I know that this side length is congruent to this side length, so K equals 13. And we can continue to use that strategy to solve for the rest. Colton, what did I say about your phone? What did I say about your phone? Put it away. I shouldn't say it out again. All right. So we can continue to use this strategy to help us solve for the rest of it. So BC, my last two letters, those should correspond to YZ. So BC, I'm told, is 2W plus 7. YZ is 3W. So I can set them both equal to each other, and then I can solve for W. How would I have to go back to solve for W on this? How can I get both of those variables on the same side? So I need a minus 2w to get over to my other side. So subtract 2w. So 3w minus 2w, that's just a single w. So w equals 7. From here, if I want to solve for the side lengths, I can plug w back in. So 3 times 7 gives me 21. So I know both of those side lengths are then 21 because they're congruent to each other. Are we okay with this so far? So our last one would then be AC and XZ. So AC is 2A. XC is, or XZ is 14. So divide by 2 to solve for A. And we get A equaling 7. We know that side length is 14. So we can use these congruent statements to help us solve for those missing variables, to help us solve for the missing sides, and sort of fill in that extra information. Once again, it's not just restricted to side lengths. It also works on angles. So if you need to match two angles together and solve for a missing angle measure, we can use that step as well. So take a moment and try this next one. So we have three variables. You have x, you have d, and we have s. So see if you can solve for each three of those variables by figuring out what is their congruent side, what is their corresponding measurements, which angles do I pair together, and see if you can solve for those missing variables. All right, so how do we go about solving for x? What do we do? What do we do for solving for x? Which angle does x represent? Or, yeah, I mean, you could do KHI or IHK, whatever, or you can just say angle H because it's pretty easy to see. So angle H, that's going to correspond to angle P, which is 90. From here, we can solve by dividing, and we get x equaling 6. Were we able to get that?
I think it's like HI and EO.
Oh, okay, so you've got as like a line segment. Sorry, this was supposed to be an angle measure. I should make that more clear. You're fine. Are you okay?
Yeah.
All right, I just make sure. Sorry, that was probably. What about for S? How do you go about solving for S? So what side length is corresponding to 4S plus 9? QR gave us JK, which was 25, and from here we could use our algebra to get S equal 4. And then our last one we had angle R for D. So R corresponded to J, 32. So 8D equals 32. And we got another variable to equal 4. Are we okay with how we were able to solve all of those? You want to match this up? That's one of the main focuses we want to get today. You want to figure out, okay, which sides are corresponding and which sides match up. All right, the other thing we want to focus on today is just being able to write these congruent statements ourselves. So we're able to read the congruent statements to solve information. The next thing is if we were to be given two shapes, how can we write the congruent statement to be able to show that these two shapes are congruent? So let's say we already know that these two shapes are congruent based off of the fact that they have all the same side lengths. So all the same side lengths on these shapes are all the same, so that should say that they're congruent. But in order to show that they're congruent, we want to be able to write those congruent statements. And so we have, what, five points on each shape? So pentagon. And so in order to write a congruent statement, we're going to need to start off with just naming one of the shapes. So I'm going to name the first one. I'm going to call it A, B, C, D, E. That's my first shape, A, B, C, D, E. And I need to figure out what is A, B, C, D congruent to in order to show that all those side lengths are matching up. I can't just write down the random letters of the other one. I need to make sure that I write them in a specific order to show that each of those side lengths are matched with its corresponding side. So the way we go about that, I need to figure out first what side length matches with AB. Which side length is corresponding to AB? IJ. So AB corresponds to IJ. BC, which side does BC correspond to?
What if we did JI?
So if we did JI, we'll then see what our mistake would be. So I'm going to write JI down here just to see what would be the issue.
JF.
So our next one should be JF, which then we can just add on that F to the end. But if you were to do this, IF don't connect to each other. And so if you figure out, like if you start with something and you see that, oh wait, that's not right, you can just switch them around. And that should help you catch that mistake on the first time. Good question, Morgan. So we have JF, and then we can keep going around, and eventually we should end up back to our start. So we went from BC to CD, which takes us to F8 or FG, H, and then we're back to I. I know some people like to write I on the end as well, and having that letter on the both sides so that it sort of connects to itself. You don't have to put the letter on the end. It doesn't matter. But that would be your congruent statement. A, B, C, D is congruent to I, J, F, G, H. I feel like I'm just spitting letters out now, vomiting up letters. But yeah, the main way to focus on a congruent statement, start with or create a name for one of them, go around its shape and figure out what each of those points are and create that name. Then go to your next shape, finding your starting point, figure out what side corresponds to start off with that shape, and then continue around until you end back up. And that should hopefully keep all of your sides corresponding and help you be able to write which sides are congruent to which sides. Are we okay with how we did that? All right. We're going to look at another example, and then we'll call it a day there. So I have this congruent statement for these two triangles. So I have two triangles here. I have my left triangle and my right triangle. So what is a name I can give that left triangle? ABD. Okay, and I want to say, what is ABD congruent to?
ACD.
So if I look to just check to make sure this is right, AB say had a single hash on it. So I need to see which triangle, which side on my second triangle, I'm sorry, had a single hash, which was AC. And then BD had two hashes. CD had two hashes, and then AD and BA are the same thing. So anytime you have two triangles that share a side length, those side lengths are automatically congruent because they're both the same length because they are the same side. And so anytime you have two things that share a property, share an angle, or share a side length, they're automatically congruent with itself because you're always congruent to yourself. You're not changing. So we call that the reflexive property. So AD is reflexive or congruent to DA because it's the same line segment. We'll talk about that more when we start proving triangles are congruent later on, but that will be an important piece that we'll talk about, that we'll bring in that reflexive property. Any questions about congruent statements or congruent shapes to start off with today? I will practice this a little bit more and build on to this as we continue throughout our week. Once again, no Friday assessment this week, but there will be one next week. That's going to be a big important one.
How many points do